So I think we are live. So hi everyone. Um, Today we are going to have a look at union and interfaces. So unions and interfaces in the next sections to the GraphQL server. So unions and interfaces are abstract GraphQL types that enables a schema field to return one of the multiple object type. Okay, so when you define a union type, you declare which object types are included in the union. It means you use the union keyword, then this media. Then this media can include both books and or movies. So a field can have a union or a list of that union. Okay, as its a return type. In this case, it can return any object type that included in the union. So like we have this type query, right? And we have a query named as all media, and this gives a list of media. Now this list can include both book and movie objects. So as we have defined here, it can include book or movie or both. All of a union's included type must be object type. So when we define a union, it has to be like whatever we are defining in the union, it has to be an object type. It cannot include a scalar, input type, etc. Included types do not need to share any field. So these two union fields do not have to share some common fields like title or anything like that. So let's have a look at an example. The following schema defines a search result union type that can return either a book or an author. So union search result, which is book or author. In the type book, we are saying that we have a title name which will be a string, and the string is like a not nullable field. It means the title has to be there. The other type is author, which contains names. The query is search, which contains a string, and then we have search result. So this search takes a parameter as contains, I think this is a parameter, and then it returns a list of search results, and those search results cannot be empty. Like the object cannot be null because we see that we have books and author, and both return some data, right? So they cannot be null. The search result union enables query.search to return a list that includes both books and authors. Then querying a union. GraphQL client don't know which object type or field. GraphQL client don't know which object type a field will return if the field's return type is a union. To account for this, a query can include the subfield of multiple possible types. Okay, so when the client starts querying, he doesn't know that what are the objects type and the fields that are there in the union object. So doesn't know which object type a field will return if the field's return type is a union. Okay, so to account for this, a query can include the subfield of multiple possible types. So here's a valid query for schema above. So we have a query get search results named as search. It contains, okay, so this was the filter, so contains Shakespeare. Querying for type name is almost always recommended, but it's even more important when querying a field that might return one of the multiple types. So we are first checking for the type name, then the notation is triple dot on books we are getting this title, and then on author we are getting the name. What is the type name field? This query uses inline fragments to fetch a results title if it's a book or its name if it's a author. So inline fragments. So here's a valid result for the web query. So when you will like query it, then what you are going to get. So first you will get the type name, which will be the object type, which is book. Then we have title, then we have type name author, then we have the name of the author. So we'll get title, we'll get name, title and name, and then we are getting type name for both of the book and the author. So for more information, see using fragments with union and interfaces. So if we want to have a look at what are the inline fragments, so like many other type systems, GraphQL schema include the ability to define interfaces and union types. If you are querying a field that returns an interface or a union, you will need to use inline fragments to access data on the underlying concrete type. It's easier to see with an example. So query hero for episode, and then we have this episode as a like query parameter. Then we have hero, then name. First we are facing the name on Android. So this is the like syntax, I guess. On Android we are getting primary function. So what is the primary function? On human we are getting the height. So here it is not returned, but in this query the hero field returns the type character. Okay, where do we have that? So hero fields return the type character, which might be either a human or a droid. Okay, so it can be a droid or a human, okay, depending on the episode argument. In the direct selection, you can only ask for fields that exist on the character interface, such as name. Okay, so like if this name exists on both the droid and human, then you can like direct query it over here. To ask for a field on the concrete type, you need to use the inline fragment with a type condition. Okay, because the first fragment is labeled as Android, direct as Android, the primary function field will only be executed if the character returned from a hero is of Droid type. Okay, got it. So we did not get height because based on the like filter like R2D2, it is just we'll get the field only primary function. Okay. Similarly for the height field for the human type. Name fragments can also be used in the same way since a name fragment always has a type attached. Okay, so this is how like it is working. So inline fragments will get this notation. So like here it was like on book, so we knew that this search query over here returns a union type which returns book or author. Then the like search query would look like this. So yep, next up we have resolving a union. So before reading this section, learn about resolvers. So we already know how to like how resolvers work. So to fully resolve a union, Apollo server needs to specify which one of the union type is being returned. To achieve this, you define a resolver type function for the union in your resolver map. Okay, so this is a little bit different. So the underscore resolver type function is responsible for determining an object's corresponding GraphQL type and returning the name of that type as a string. It can use any logic to do so, such as check for the presence or absence of fields that are required that are unique to a particular type in the union, using instance of if the JavaScript object type is related to GraphQL object type. Here's a basic resolver type function for the search result union defined above. So let's see how like resolvers will work. So we have resolver, then we have the search result resolver. Now we are creating something like this. So resolver type object context info. So these are the like parameter we get in the resolver. So only author has a name field. If object.name, it means if the object has name, then return author. If object has title, then return book. Else return null. So then we have query, then we have search, then there will be a function, and then like this is the whole actually entire GraphQL server. So we have resolver, then we have query, then we are getting type defs, and then resolvers. Type definition is that will be defined maybe over here, this one, type def. So this is how it is working. A resolver type, so yep, object based on the object parameter that we are getting, we'll see if it contains name or it contains title, will return accordingly. So if a resolver type function returns any value that isn't the name of the valid type, the associated operation produces a GraphQL error. So GraphQL error is thrown. Okay. Now we have next up interfaces type. So an interface specifies a set of fields that multiple objects types can include. So we have one interface name is book, then we have title, and then we have author. Title returns a string inside book, and then author returns a author type. If an object type implements an interface, it must include all of the interface fields. Yep, so interface like as in the mathematics, union and interfaces, right? So interface is the common of the both field, the fields that are in set A and set B, right? So in the same way it works here. So suppose that we have another type as a textbook and it implements book, then it will have to include the title, and the author must represent, like these two fields must represent because they are defined in the interface. Then we have another field as courses, so this might be defined somewhere else. A field can have an interface or a list of that interface as its return type. So in this case it can return any object that implements that interface. So type query books, and then it returns books, and then can include textbooks objects. So example, let's have an example, like it is always better to look at an example. So the following schema defines a book interface along with two objects types that implement it. So we have one interface name as book, which contains title and a string. Then we have author. Excuse me. Then we have one type name as textbook, which implements the book interface. So it has to include the title and the author. So these two fields has to be there. And then we have another field as courses. Then we have coloring book, implements book, then title, author, and then the colors. Then we have this query book as books. So as we saw here, right? So this is how it is working. So whatever interface you are going to implement, you will have to include the fields inside that interface in your next type. So in this schema, query.books returns a list that can include both textbooks and coloring book. Okay. So querying an interface. Now if a field's return type is an interface, clients can query that field for any subfields included in the interface. So query, then we have get books, and inside the book we have title and author. Client can also query for subfields that aren't included in the interface. So books, then type name, then we will query the title, then on textbook. So inside the textbook we have these many fields, courses, right? So he can name like query for courses, and then the name of the courses only present in the textbook, then coloring only present in the color book, so color book type, right? So client can query the fields, subfields that are included in the interface. So the interface included only the title and the author, but it did not include the courses, right? But because this book query returns a list of books and it contains title and author, but this is an interface, and this interface has been implemented inside this textbook and then coloring book, right? So the client can actually query for these fields even if book does not contain title and courses and colors, right? So you can see in this query, like books query, we are first fetching the title, and apart from that we are also fetching on textbook, courses and names, and on coloring book and then courses. So this query uses inline in fragments to fetch a book's course if it's a textbook, or its colors if it's a coloring book. Here's a valid result for the query. So we'll get a textbook, then the title, then courses, then we have like coloring book. For the coloring book we'll get the title, and then we'll get the colors, right? So resolving an interface, then how do we write the resolver? So as with union type, Apollo server requires interfaces to define a resolver type, underscore resolver type, resolve type function to determine which implementing object type is being returned. So here is an example. Resolve type function for the book interface defined above. So we have resolver, then book, then resolve type, then we are getting book. So first argument is book, then context, and then info. So if book.courses, then return textbook. If book.colors, then return coloring book, right? Otherwise return null. So this is how it was. So next up we have custom scalars. So what are the custom scalars? So in the very beginning we saw that we can also define our own scalars, right? So this is the one, I guess. So let's have a look. So the GraphQL specification includes default scalar type as int, float, string, boolean, and id. Although these scalars cover majority of use cases, some applications need to support other automatic data types such as date or add validation to existing type. To enable this, you can define custom scalar type. So like you might say that I need one more scalar type such as date or something entirely different, which is like relevant for your use case. So in that case you might think about like creating a custom scalar. So defining a custom scalar, to define a custom scalar, add it to your schema like so. So scalar, you use the scalar, and then you have this field my custom scalar. You can now use my custom scalar in your schema anywhere. You can use anywhere you can use a default scalar, that is as the type of the object field, input field, or an argument. So however, Apollo server still needs to know how to interact with values of this new scalar type. So you just define the name of the scalar as my custom scalar, but you have to define that what this scalar has, like what are the definition. For the integer, it knows that GraphQL knows that whatever data that I'll return or receive or like send as a query parameter, it has to be integer like 1 2 3 and something similar. It cannot be like float value or string value or boolean value, otherwise the GraphQL will throw an error, right? But the same goes for the my custom scalar. So you will have to define the rules that what this custom scalar will contain. So defining custom scalar logic, that what it will contain. After you define a custom scalar type, you need to define how Apollo server interacts with it. In particular, you need to define how the scalar's value is presented in your backend. This is often the representation used by the driver for your backing data store. How the value's backend representation is serialized to a JSON compatible type. Then you will also have to take care that how it is serialized to JSON compatible types. So JSON has some types, right? So you will have to take care of that as well, because I guess the return will be a JSON type. So how the JSON compatible representation is deserialized to the backend representation. So first serialization, and then you will have to take care of deserialization, both at the front end and the back end. So client and like when you send, you will get send a JSON type, right? So let's have a look. We'll have a better picture, I guess. So you define these interactions in an instance of the GraphQL scalar type class. So we have a specific class for this. So example, the date scalar. So let's have a look at the date scalar, right? So the following GraphQL scalar type object defines interaction for a custom scalar that represents a date. And this is one of the most commonly implemented custom scalar. It assumes that our backend represents a date with a date JavaScript object. Okay, so it assumes that our backend representation represents a date with the date object JavaScript. So let's have a look. We have this GraphQL scalar type, and then we have kind. We are importing from GraphQL. Then we have date scalar, which is like implementing on GraphQL scalar type. Then we have these are the fields. This is how you define. So first you define the name of the custom scalar type, then the description of the custom scalar type, then serialize how this value is serialized. So it takes value, then return value dot get time. So this is how we are returning. So converts outgoing date to integer for JSON. Get it? So this value dot get time, right? It will convert the outgoing date into integer for JSON. So it will convert this whole value will be an integer, I guess, and then that integer can be used as a JSON object. I mean as a JSON field. So serialized. This is the serialization. Then we have another function as a parse value. It takes value, return new date value, converts incoming integer to a date. So this does the reverse of serialization. So parse value, it will return it will convert that integer type into a new date object. Now we have parse literal, which takes est. I'm not sure of this. So if est.kind is kind dot int, so this k is capital and this ent, then return new date, parse int. We are using parse int est.value and 10. What this does, convert hard coded est string to integer and then to date. Okay, so suppose that we have sent a hard coded string like January 1st 2020. I'm just guessing. So then first it will convert a string to the integer and then to the date. So new date, right? And then parse int integer value, then est.value. Otherwise return a null, invalid hard coded value, not an integer. So this initialization defines the following methods. So we are initializing the this date scalar. So it contains this serialize, then parse value, then parse literal. Together these methods describe how Apollo server interacts with the scalar in every scenario. So let's have a look. So first we have serialize, which was like actually taking the value and then sending data, which can be like represented inside a JSON, I guess. So the serialize method converts the scalar's backend representation to JSON compatible format. So Apollo server can include it in an operation response. Yep. So Serialize has to send a data type which is supported inside JSON format. So because this JSON format will have to be sent ultimately at the client side. So in that case, you just cannot expect the client to receive some like any data which is not supported by the JSON. You will have to send convert it to the JSON type. So in the example above, the date scalar is represented on the backend by the date JavaScript object, as we can see here. So this is a new date value. So when we send a date scalar in a graphical response, we serialize it as an integer value returned by the getTime function of the JavaScript date object. So this getTime function actually returns. So suppose that I'm more lending the new date July this, and then we have then if we log the getTime, then we have 6. I guess so we have this I guess it is epoch's value. Let's say the getTime method returns the number of milliseconds since the ECMAScript epoch. Yep, this is the epoch value. So you can use this method to help assign a date and time to another date object. This method is functionally equivalent to the value of method. So yep, so it sends us epoch value of that time. So here that we see that this getTime will return an integer which might be in the negative or positive based on the time. So this is what the serialize function is doing. Then we have parse value. Now this parse value will convert that integer into back to the date object in the JavaScript. So the parse value method converts the scalar JSON value to its backend representation before it's added to the resolver's argument. So yep, so in the resolver we get this arg argument as well. So we'll have a look at those. So what this parse value does is that it takes the argument from the JSON from the client side, and then it converts back to the serialize. Like this is the just reverse of the serialization. So Apollo server calls this method when the scalar is provided by a client as a GraphQL variable for an argument. Okay, so Apollo server calls this method parse value when the scalar is provided by a client as a GraphQL variable for an argument. So what is this GraphQL variables? Okay, variable name. So far we have been writing all of our arguments inside the query string, but in most applications the argument to fields will be dynamic. For example, there might be a drop down that lets you select which Star Wars episode you are interested in. So a variable is this like we define it by this $sign. So here in the hero name and friends we have one variable episodes which takes episode. Then we can pass that variable as a episode in the hero query, right? And then we see that in the variable it is white light over here, but in the variable we are passing that episode at JD. So this is how it is working. So the parse value converts the scalar. Okay, Apollo server calls this method when the scalar is provided by client as a graphical variable for an argument. When a scalar is provided as a hard-coded argument in the operation string, parse literal is called instead. Okay, so parse value is called whenever we pass our query as a variable, which we saw. This is how we pass a query. So hero name and friends, right? So suppose that we have this query hero name and friends, then we are passing one variable name as episode. Then we have this hero query which takes episode as a parameter. which is a variable which is defined over here, and then that variable value is this. So whenever we like pass as a variable, then this parse value will be called on that custom scalar. But let's have a look. So then we have this parse literal. So parse literal is called when we pass it directly as a filter. So like if we would have passed over here episode as JD directly over here, it was not defined as a variable, but this JD would have passed as a string over here, then in that case I think this parse literal will be called. So when an incoming query string includes the scalar as a hard coded argument value, right? So instead of using variable, we are just hard coding the JD value, right? So that value is part of the query document's abstract syntax tree AST. So Apollo server calls the parse literal method to convert the value's AST representation to a scalar backend representation. In the above example, parse literal converts the EST value from a string to an integer and then converts the integer back to the data, having date matched to the result of the parse value. So we can see that over here it finally returns a new date, right, and JavaScript date object. So parse literal, when we have this as a EST, what was that EST abstract syntax tree, when an incoming query string includes a scalar as a hard-coded value, that value is part of the query document's abstract syntax tree. Got it. So that query will be a part of the EST. So actually GraphQL creates a abstract syntax tree of all the queries and the like parameter and all the fields that are available. So that hard-coded value will also become a part of that EST. So now we are getting that EST. Then if est.kind is a kind.ent, like integer value, then what we are doing, that first we are parsing that to the base 10, right? Yep. So suppose that in the parse value we were getting an epoch value as an integer, then here we are converting that epoch to the new date. But right now first we'll have to check if it is integer type, then we will first like convert it back to the base 10, I guess. Then what we are doing is that we are converting that whole integer back to the new date object. That is serialize, that is parse value, then and parse literal. Okay, so providing custom scalars to Apollo server. Providing custom scalars to Apollo server. After you define your GraphQL scalar type, so first you define named it as a scalar, my custom scalar. Then you define this whole function to actually define the rules and the logic for that is custom scalar. Then after you define your GraphQL scalar type instance, you include it in the same resolver map that contains resolver for your schema, other types and fields. So here we have Apollo GraphQL and GQL. So let's have a look. So then we have this custom scalar type definition. Then we are defining this scalar type, scalar as a date. Then this event contains that scalar as a like abstract type, and then this query events send such events. Now we have this constant scalar definition where we are defining the all the logic for that scalar. Then we have this resolver. Now what you just need to do is that to include it, you just need to write this. So date, which is a scalar, and it is mapped to the date scalar, which is this. So now the resolver will know how to do it. So we can see that if it is int or date, and then inside the Apollo server we can include the type definition in the resolvers. So let's have an example, restricting integer to add values. In this example we create a custom scalar called odd that can only contains odd value. Okay, so let's have a look to understand this. So first we have Apollo GraphQL server, then GQL, then user input error, then GraphQL scalar type, then kind. First we are defining the type definition. So GQL is scalar, we are defining this odd. Then we have this query type, echo odd, so it contains, like, it takes odd, and then it has to be the odd value, and then it returns that. Now validation function for checking oddness. So function odd value, it takes value, then if type of value is number, and number dot integer is integer value, and value wait, and then we are checking if value %2 is not equal to 0, it means it is even, I mean it is odd. Then in that case what we are doing is that we are returning the value, so that is a value, and I mean that is an odd number. Throw new user input error, provide value is not an odd integer. Then we inside the resolver, what we are doing, like we are defining this as odd, and the new GraphQL scalar type, this one. Okay, inside the resolver itself we are like defining all the logic. So this is by the way, here we saw that Tate scalar was a totally different like logic, but here we are defining it inside the resolver itself. So name odd, then description, then parts value, which is odd value. So and then serialize, which is odd value, and then parse literal, so est and then kind of integer, then return odd value, parse and est value 10, and otherwise throw an error. Then we have this query echo odd, it takes this odd, and then return if it is odd. So if I can, then let's see if this works, this whole code works or not. Terminal. Okay, so yep, I guess we can, let's leave it. I'll create another one. So let's rename this index 1, then we can create another one index, right, just for now, and then I'll copy this code, entire code, and paste it over here. Let's save it. So I guess it should run, and then let's npm start. It is running on this port. Let's remove it. So we have one odd query, so query echo odd, so query, how were we defining the queries, I forgot. So query and then get odd, then like this. Okay, so let's define it over here. Instead of, I can just comment it out, then we can define one more query. So query, then maybe name it same, echo odd, or let check odd, actually not exactly checking, but yeah, okay. So then we have the query as echo odd. Now you can see that it popped out, it takes a variable as null. So wait, let me show you. So like this sandbox itself, what it did is that it converted my query into a variable based query. So this check odd is taking one variable which is odd, and then that variable is being passed as odd, right? So now inside that odd, what is happening, like it is taking an argument. I guess this is a valid query. Now if I pass it check odd, variable odd got invalid value 8, expected type odd, provide value is not an odd integer. If I send 7, yep, then echo odd is 7. So now you can see. So let's have a look what happened actually. So first we define this is scalar, and then actually let us do it like this. So here what was happening is that we had defined this in an entirely new state scalar. Then let's define this odd scalar as well. So odd scalar Scalar new graph follow server, and then let's copy this entire thing over here. So cut and then paste, but before that so, and then what we will do, we will copy this odd scalar over here. So this is good to like decouple everything. So this will again work the same. So if I check odd, then it will echo odd. If I pass 10, then it will throw me an error like expected type odd, provide value is not an odd integer. So yeah, this is how it is working. So let's have a look again. So first we have type definition, and then we are defining this scalar odd, then query, then echo odd. It takes odd as a parameter, then it returns the odd as well. So now what is this odd? Like you can see that here we are passing is at a scalar type. So how do we define this odd? So this is how we define the odd scalar. I mean, this is where the mapping is happening. So first odd is taking odd scalar. What is odd scalar? It has name, then description, then parse value. Then parse value is itself is a function. So it takes a name, a value, and then it checks if the value is odd or not. If it is odd, then it returns the value. If not, then it throw an error, provide value is not an odd integer. And then if I put an exclamation, then you will see that exclamation is also there. So this is the exception that is being thrown. So let's remove this and this. Then we have odd integer, that you can see that those 3 exclamation were there. This is how it is working. So we defined the odd value functionality, and then we mapped it out over here in the odd scalar, and then we defined the 3 things like parse value, serialize, parse literal, and all those things. So this is how it is working. The next thing is now inside the resolver we had this query, then echo dot, then the first parameter is empty, then the second parameter we are just like extracting the odd variable. Like we could have done arg.odd, but we are just extracting the variable, and then we are returning the returning the odd variable simply. This is how it is working. So yep, returning the odd, because this echo dot returns an odd scalar type, then all the checks on that scalar type will be applied. So yeah, this is how the scalar type, custom scalar type is working. Okay, so now importing a third-party custom scalar. How do we now? Suppose that for the date one we have a third-party scalar, we do not need to like write all this logic, right? So suppose that we needed a custom scalar type, and that scalar type has been implemented by someone already. Then how we'll do it? So in another if another library defines a custom scalar, you can import it and use it just like any other symbol. For example, GraphQL type JSON package defines the GraphQL JSON object, which is an an instance of GraphQL scalar type. Okay, so you can use this object to define a JSON scalar that accept any value that is a valid JSON. So suppose that your scalar type was a JSON object which has if it is not JSON, then it will throw an error. So how do we include the third party scalar type, custom scalar type? Is that first we install it, so GraphQL type JSON, then require and GraphQL JSON object, then require. Okay, then we imported it, GraphQL JSON. Then again first we define the scalar as JSON, just like we did in our custom scalar. And then my field will send me JSON object. Then we have just like that, we can just write it over here, this constant value. Then all the implementation is right behind the package. So this is simple. We are doing these two things. We'll define the mapping, then we'll define the scalar type in the type definitions. Okay, so this is how it is working. Okay, so next we have directives. I'm not sure what are these, so let's have a look, because time is about to finish for this Pomodoro session. Then I think let's have a look. So defining a schema, so schema basic, union and interfaces, then custom scalar type, then we have directives, then we're creating directives, then fetching data. So first defining a schema, then fetching the data, then development workflow, build and run queries, request format, mocking, integration testing, and all those things. Then we have this performance, then we have security, then we have deployment, then we have monitoring, then we have API references. There is too much to read about, so let's see how it goes. So for now we saw a lot of things. Okay, so for now we are just finishing the defining a schema. Then next up will be fetching data, which will include all about resolvers and error handling and all those things. So it also actually includes subscriptions. So resolvers, then data sources, what are the data sources that can be there, then error handling, then file upload, subscription, and then we have development workflow, like how the whole development will work, integration testing, mocking, request format, and all those things, right? Then we have performance and security and all those things in the GraphQL server. So what do we do for the 2 minutes, because I want to start this topic once the Pomodoro starts. But let's have a definition of the directive actually. So configure GraphQL types, fields, and arguments. This is what that directive does. Okay, a directive decorates part of a GraphQL schema or operation with additional configuration. Okay, tools like GraphQL Apollo server and Apollo client can read a GraphQL documents directive and perform custom logic as appropriate. So directives are preceded by the @ character, like so. We have this example type. Then we have old field, which will return a string, and then we have this deprecated. Then we have a region, use new field. Okay, this example shows the deprecated directive, which is a default directive, that is it's part of the GraphQL specification. It demonstrates the following about directives. So directive can take arguments of their own, a reason in this case. Okay, so directive can also take argument, and then directive appears after the declaration of what they decorate. So they are appearing after the field itself, the odd field in this case. So let's start after let's start afresh after the break. So this is break time, I guess. And yep, So let me start the timer again. So Pomodoro interact, and then change the timer, and it is running. Okay, so I think we are back. Let's start the timer. So yep, we were going to have a look at directives. So configure GraphQL types, fields, and argument. So uh, this is how, like, basic. So a directive decorates part of the GraphQL schema or operation with additional configuration. So as you can see, you can configure a GraphQL type or a field or an argument with some additional logic or configuration. So tools like Apollo server, Apollo client can read a GraphQL documents directive and perform custom logic as appropriate. So right now, like we saw that we are applying a deprecated directive on this old field, so that the client will know that this old field has been deprecated and it might be removed in the future updates. And then we are supposed to use the new field. So in this example shows the deprecated directive, which is a default directive. It's a part of GraphQL specification. It demonstrates the following about directives. So directive can take argument of their own, such as we saw that reason, and directive appears after the declaration of what they decorate. So they appear after of whatever we are applying on. So valid location, so each directive can only appear in certain location, so their location are also defined within a GraphQL schema or a operation. These locations are listed in the directives definition. So for example, here's the GraphQL specs definition of the deprecated directive. So directive, so like how it is implemented in the backend. So directive we are using this directive keyword, and then we have this name of the directive, which is deprecated. The reason will take a string, no longer supported. For example, it is there on field definition, then argument definition, and then input field definition, and then enum value. So these are the fields where we can use this directive. So this indicates that deprecated can decorate any of the four listed location, like on the field or on the argument or on the input field or on the enum value. Also note that that its reason argument is optional, and the reason is optional. You can see that string does not include that exclamation mark. So and provides a default value, like no longer supported. So usage example of each location are provided value, so below. So let's see how this deprecated is being used on these four fields. So first we have directive. um, so argument definition, so note that deprecated argument must be optional. So deprecative, directive, and then with deprecated args that we are defining, that then deprecated arg is containing a string, and then we are using that deprecated directive on this deprecated argument field. And then we have new arguments, which returns string on field. So we can see this is being used on the field, so this one is a field, right? Then we have this my type. Then we have argument definition, alternate example on fields argument. So we field with deprecated args, so name is string. Now here we are using as a like using this deprecated directive on a argument. So we can see that it was argument, right? I mean, it can be used on the argument as well. So name is an argument, which is a string, but this one is being deprecated, like in the future it might not be there. And then we have argument definition, then we have field definition. So deprecated field is string, and then we are using this deprecated. Then on the enum we are using this deprecated, and the reason use new value, and then we are using as an input as well. So we saw that enum value, input value, argument value, then the field definition. So here on the, this is not deprecated input, and this is deprecated input, which is a string, and then we are using this deprecated directive. So if deprecated appears elsewhere in a graphical document, it produces an error. So according to this definition inside the GraphQL, if you define this deprecated directive anywhere else, then it will throw an error. So schema directive versus operation directive. Now let's have a look. So over here we saw that all the directives that we were applying were on the schema definition. So I think there is some difference between schema directives and operation directive. So usually a given directive appears exclusively in graphical schema or exclusively in graphical operation, rarely both, although the specs allowed this. So let's have a look. For example, among the default directive, deprecated is a schema exclusive directive, and skip and include are operation exclusive directive. So what are the operation exclusive directive? We'll have a look. So the graphical spec lists all possible directive location. Schema locations are listed under type system directive location, and operation locations are listed under executable directive location. So default directive deprecated, so region was a string, and then skip if then it takes so like marks the schema definition of a field or enum value as deprecated with an optional reason, and this skip, which takes an if as an argument, which returns a boolean, it takes a boolean. So if true, the decorated field or fragment in an operation is not resolved by the graphical server. Okay, so if you are trying to like skip a resolver, in that case, like you suppose that you have defined a query and there is a resolver, but if you want to skip that resolver, you do not want to return the query, then you will use this skip as true or false. Okay, and then include. If false, the decorated field or a fragment in an operation is not resolved by the GraphQL. So include false. Okay, so skip, if it is true, then it will skip. Include, if it is false, then it will not resolved by the graphical schema. So it is like used in resolver, I guess. So dot skip decorative GraphQL, not skill dot skip. Okay, so we have this query. It returns ID title skip if skip title. Okay, then GraphQL variable true, skip title true. Include if include other, then name GraphQL variable include other false. But in the backend, where do we use it? How do we use it? Okay, so GraphQL server. So mutation, sign up, then hey, this guy, the graphical validation using directive. So this is just guest box. Out of the box, GraphQL supports validating your inputs based on the type of information. For example, you can ensure that an argument is a particular scalar type, such as a string or int. You can also enforce the shape of the object argument using the input type. While this prevents a large class of possible error, this doesn't cater to more complex validation needs like enforcing the length of a string or the size of the number. So a simple example, you use a sign up form. To see how schema validation could be used, it's easier to start with an example. So this is the STL. So email, password, first name, last name. Then we have the mutation sign up, which takes input, sign up input. So this is the sign up input. In the web interface, this is what it is. Today, people most commonly write this kind of validation logic in their resolver function or models. However, this means we can't easily see our validation logic, and we have to write some repetitive code to verify this same kind of condition over and over. Okay, so yep. So the above enforces all the fields are string. Okay, and ensure that they are not null. However, we have got some additional constraints that come from the database that we need to be wary of. In our server, the backend database is using varchar 255 field for all the string. So all of these fields are stored as a varchar. This means providing a field greater than 255 character will cause an error. So all this field, email, password, first name, last name, are the maximum length can be 255. Today, people most commonly write this kind of validation to their resolver function. So when the query hits and then when it goes to the resolver, then what you do, you write your logic over there. Okay, so whatever we are getting as a argument or a parameter to the query, then we write logic that if it is a number, integer, or like what is the length of the argument, like those. So however, this means we cannot easily see our validation logic. So we'll have to go to the code base to like see how they are being used, and we have to write some repetitive code to verify the same kind of condition over and over again. The new option, validation with a schema directive. So instead of like defining all your logic in the resolver, you can use directive. So it's possible to add this logic directly to your STL using new module, GraphQL constraint directive. This module exposes a constraint directive to decorate an STL with a validation rule. So whatever you validation you want to apply, you can use that directive, and you can import this. I mean import I guess constraint directive, and then you can write your own logic. So thanks to GraphQL tool and Apollo server, it's easy to integrate them. Here's how you do it. So first you will install GraphQL constraint directive, then make executable schema from the GraphQL tool, then constraint directive, then we have the type definition over here, so all the type definition, then schema. In the schema, make executable schema. So type definition, then schema directive it is taking, and then constraint. So it is taking as an like option of constraint, which includes constraint directive, which is over here. After this few line of configuration, it's now possible to decorate any part of your STL with constraint to attach validation rule. A full example can be found in the GraphQL constraint directive readme. Here's how your STL will look with some of the constraint directive. So so we imported this constraint, right? And these are the like configuration in initial configuration that you will have to do. Once we have done that, then we can directly validate our fields with the constraint directive, such as the constraint will have some like predefined inputs such as format. So format will be email, then maximum length will be 255. So like if someone passes just the name or just a word, then it will throw an error that email is not valid. And then we have password. So constraint length is like just it has to be 255 character maximum length. Then we have first name, then the name should contain like 0 to 9, A to Z, and A to Z, and maximum length is 255. Same goes for the second name, although I'm not sure why are we including numbers in the name, but leave it. So and then we have the mutation. So you can see that we are defining all those directives directly. Like if we were not doing like this, then what we'll have to do is that in the resolver function over here, so suppose this was odd, right? Then what we'll do, we'll write logic that if odd is like odd, something like that, and then we will check all the our logic, and then we'll return the response. But with this decorative, what we are doing, we are directly checking on the field itself, schema definition over here. So in the type definition, suppose that this was the field, then what we can do, we can directly apply a constraint, right? Constraint and then like write the logic that what will be the format and all those things, right? So this is how we can implement it. Okay, looking at the example in detail, so let's break down the example above. So like it takes email in maximum length. So if just we got the like gist, receiving validation error on the client, and this is how you'll receive the validation variable input got validation like invalid value. So email foo which you passed, so expected type constraint string as a value dot email must be in the email format. So this is how it will throw an error. How does the constraint directive work? So there's something interesting about the error message above. Specifically it says expected type constraint string even though the field is defined as a string. Yep, so you can see that as soon as we applied the constraint, then the type, I guess the type got changed. It got changed to the, I guess, constraint directive something, right? So let's have a look. So constraint string okay, the constraint directive wraps each field with its own scalar type. Yep, so it has defined its own scalar type, and then it will wrap the like your field such as email which was a string with its own like scalar type. So graphical tool takes care of it, this implementation detail for the consumer. So the field in question can still just be the type of string when submitted the mutation. Constant string and constant number will never appear with your schema definition, and the client consumer need not to be concerned about it. So like it will not be something which will be visible to the client side that okay, this email is not a string but it is a constant string or whatever it is. So he will not have to worry about it, that when the value of each decorative field is passed, the validation rule are executed. For example, here's the code for minimum length. So this is the code for the minimum length. So minimum length and it's not length, and then throw graphical error and all those things. If all validation rules and all. Okay, so this is thanks for this guy. This was helpful. It is on Apollo GraphQL itself. Okay, so creating schema directives. Next up we have how do we create a schema directive. So before you create a custom schema directive, learn about directive. So we just saw what directive does. So suppose that if you want to create our own directive, which we will because like in some cases you might need some custom validation. So your schema can define custom directive that can then decorate other part of your schema. So how do you define the custom directive definition? So we use directive keyword and then the name of the directive, and then on what field we are going to apply this directive. So it will be applied only on the field definition. So like this hello is a string, right? And then we are applying this uppercase directive. Now how do we like write the logic so that logic can be written? So see an example implementation of the directive in the code box. Okay, when you start your app, you can use Directive to transform your executable schema behavior before you provide that schema to Apollo server. For example, you can modify resolver function for any decorative field. For the schema verb, it could transform the hello resolver original result to uppercase. So how do we define it? So directive then deprecated. A directive definition looks like this. So how do we like actually define it? So first we use the directive, then the name, then reason, no longer use, and then on what are the fields that it will be applied on. This is the definition for the deprecated directive. The directive takes one optional argument, reason. The directive can decorate any number of fields like field definition, enum value, or and all those things. So supported location. What are the location where it is supported? So these are the location. So your custom directive can appear only in the schema location you list after on keyword in the directive definition. So here you see that we are using this on keyword, right? So what are the fields it can support? So the table below lists all the available location in the GraphQL schema. Your directive can support any combination of these locations. So you can define it on a scalar type, on object type, on field definition. Okay, so scalar type, the definition of custom scalar. Okay, then object type, definition of the object type. Then field definition. So definition of a field with any defined type except an input type. And then we have argument definition, we have interface, we have union, we have enum. What is the difference between enum? Okay, the enum type and enum value. Okay, and then we have input object. Okay, and then we have input field definition, input object field, the definition of the field within the input type, and then schema. So top level is schema object declaration with query mutation. Root object, we can also define it on the root object. Now let's have a look at implementation. So Apollo Server 3 does not provide built-in support for custom directive. To enable this support, you need to install certain graphical tools libraries. So as we saw in that article. So this article uses Apollo GraphQL tool version 8. Previous version previous versions use a different API for custom directive. If you are using an earlier version of the GraphQL tool, see the below GraphQL tool. After you define your directive and its valid location, you still need to define the logic, of course. So here what we did is that we named a deprecated directive by the which is like included by default, and then we define the reason for this directive and then on which field it is applied. But if you are creating a custom directive, then you will have to define the logic as well, like email or odd or even, or if the field is or if the field contains a number or not, something like that, right? So you also need to define the logic, right? So define directive logic. How do we define the directive logic? So to define what Apollo server does when it encounters your directive, you can create a transformer function. So these are known as transformer function. These functions, this function uses a map schema function to iterate through location in your schema, field definition, type definition, etc., and perform transformations whenever it encounters a particular directive. So for example, here's a possible transformation function for the default deprecative directive. So what is happening, like this is a very big field. So deprecated directive, transformation schema, directive map schema, and all those things. Like I don't think I'll go with it, but you can see that this is how it is defined. So mapper kind, object field, field configuration, execute once for each object, field definition in the schema, execute once for each enum value defined in the schema, and like so for different types we are like writing the functions. So as shown, the second parameter you pass map schema, this is I guess the first, The second parameter you pass a schema is an object with keys that represent one or more location in your schema. Okay, so this is the schema and this is the map schema, the whole thing. With keys that represent one or more location in your schema. The mapper kind enums for each of the supported location is listed in the above. Example, uppercase sing string. So suppose you want to convert a certain string fields in your schema to uppercase before they are returned. So this example defines an uppercase directive for this purpose. Click to expand. Let's have a look. So what it is doing, Apollo server, GraphQL, make executable schema, map schema, get directive, mapper kind, default field resolver. First what we did is that we defined this directive upper on field definition only. Then we have query hello, then which returns a string, and then the directive upper. Now inside the resolver, we are just returning the hello world. Now this function takes wait, launch Apollo. Can we like remove this section or this section? Okay, so yep, let's have a look. So this function takes in a schema and adds uppercasing logic, okay, to every resolver for an object field that has directive with a specific name using the upper function upper directive transform schema directive name return map schema, and then mapper.kind object field field config, which is like same as upper. Then we are defining this constant upper directive, and then it is using the get directive function schema field configuration directive name, then if upper directive, if there is upper directive, get this field's original resolver, resolve default resolver, then field configuration, then replace the original resolver with the function that first calls the original resolver and then converts its result to the uppercase. Okay, this is how it is working. So field configuration dot resolver async function source argument context info, then it is first awaiting to resolve, then if the result is a string, then return result dot up to uppercase, otherwise return the result, or at the end return field config. And then we are make executable schema type definition resolver, then we are using the transform the schema by applying the directive logic. So upper directive transform schema and then upper, it will be applied on the whole schema, then server starting the server and all those things. So this is how, if you want to dig deeper into like defining your own custom directive, then this is how you will do it. I think it is like this would have been, but it is good because like if we were to define this uppercase logic in our resolver, then we will have to write that logic or at least import that logic in every resolver where we want to return an uppercase string. But using this directive function, we can simply just use this one keyword like one directive on the field definition, and then it will be good to go. So it is somewhat like saving some space, and like it is easy to read and all those things, so it is like good in my opinion. So yep, additional example of transforming executable schema with directive, and this see the GraphQL tool docs, although will not go with all the things, but still okay, this is how they are doing example and all those things, fetching data from RESTful API. This was for what, GraphQL schema directive name string. So this is how they are using the uppercase directive. Okay, leave it. By the way, this did not open at all. Oh, it did actually. Yep, so it is same code. So if I copy this directive index, this was like base index base. Then we have this latest index, what we learned in this scalar type, right? Then custom scalar type, right? This was for custom scalar type. Then let's create one more and copy the code. And this is custom directive. So upload GraphQL, importing all the things, and then like we are using this upper, then all the things, right? And by the way, we also had to install something, right? Yep, this one. Tools. So let's kill the server and then run it. And this is all I needed. Yep. So GraphQL tool schema, then GraphQL tool utils. Once it is installed, then next step is resolver. So schema definition is finished. Next is resolvers, data source, error handling, file upload, and all those things. So it is installed and npm start. And if I go to the Apollo Explorer, so we have this, what are the definitions? So we have this query hello, which will return a string, and which will return a hello world. But if we execute that query, okay, so we have this hello string, right? Let me execute it. So if I execute query hello, then this picks hello, and that's all it. And if I return, then you can see it is returning an uppercase of the hello world. So we defined this directive. So suppose that we are using one more query name, right? Gives me a string, and then we are using this upper directive. Then in the resolver we have this resolver for hello, then we will have resolver for name, right? And then this is a function which returns like suppose Akash Giri, right? So if I execute this name query as well, hello, and then name, you can see that Akash Giri is capitalized, right? So we passed it as a small case, but because we use this upper directive, it is being capitalized. So this is how it is working. What about query directive? So although directive syntax can also appear in the GraphQL queries sent from the client, implementing query directive requires runtime transformation of query documents. We have deliberately restricted this implementation to transformations that takes place at server construction time. We believe confining this logic to your schema is more sustainable than burdening your clients with it, though you can probably imagine a similar sort of abstraction for implementing query directives. So you can also implement query directive, which I guess the client will have to implement at their own end, I guess. So if that possibility becomes a need for you, let us know. So right now they like Apollo server has not, I mean Apollo has not, Apollo GraphQL has not like implemented that. Next up we have fetching the data. So first we defined all the data. So schema basics, unions and interfaces, custom scalars, directive and creating directives. Now the next part will be mainly focusing on this part, this resolver part. Before that we focused on the type definition part, which is like schema definition language SDL. So how Apollo server process graphical operation. So whatever query the client makes, how the data is returned, that will be mostly the part of the graphical resolver part. So inside this resolver we'll be able to see the one that I was talking, what are the arguments that resolver gets and all those things. Okay, so which is quite big, and I'm thinking that I'll start this later because I need a little bit of time to read. But let us have a look at actually just the basic what you will see. So resolvers. So how Apollo server process the graphical operation. So Apollo server needs to know how to populate data for every field in your schema so that it can respond to request for the data. Let's start this somewhere later. So we'll finish the stream for now. We'll start it from tomorrow. So thank you.